Good day, my dear students. In this video session, let us learn how to derive the shape functions for 8-noded hexahedral element. 8-noded hexahedral element is one of the three-dimensional element used in FEM. At each node, 3 degrees of freedom, x, y and z component of displacement. 8-noded hexahedral element is also called as a brick element. It is one of the three-dimensional element and it is one of the solid element. Okay. And let us derive the shape functions for this hexahedral element. This 8-noded hexahedral element, it consists of 6 faces as shown in this figure and 8 corners and 12 edges. Okay. Now it is a 8-noded. All these 8 corners are numbered as nodes, 8 nodes. Okay. Now let us draw the sketch of this element, hexahedral element, 8-noded hexahedral element. Represent the directions, 3 directions, 3 coordinates. In natural coordinates, we are deriving these shape functions. Now let us represent this direction as zeta. Now represent the directions, 3 directions. This direction represent as zeta, and this direction neta, and this direction phi. Okay, show these directions zeta, neta and phi. Okay, and let us number the go for numbering the nodes. Node number 1, 2, 3, 4 and anti-clockwise, and top face also. Node number 5, 6, 7, 8. Like this, number the nodes, do the numbering of 8 nodes like this. After that, write the natural coordinate values. The origin of these natural coordinates will exist at the center of this element, hexahedral element. Okay, what is that? Wherein zeta, neta, phi. In this fashion, you should write zeta, neta, phi, and it is 0, 0, 0 at the center. Okay. Now, with respect to this origin, let us write the natural coordinate values of all these nodes. Okay. How do you write? It will be very simple. If we write the natural coordinates of all the faces. If we consider this face, front face, having the nodes. Okay. Here the front face is having the nodes 2, 3, 7, 6. Okay. This face is approaching in zeta direction like this. Front face and the back face are approaching in zeta direction. Okay. Now first I will consider the front face. Okay. Now front face, it is in the same direction that we have considered, that is zeta. Then zeta is equal to plus 1 for this face. Okay. For this face, zeta is equal to plus 1. That means the nodes which are at node number 2, node number 6, node number 7 and node number 3, this zeta value is 1. Zeta is equal to 1 as we wrote here. For node number 6, zeta 1. For node number 7, node number 2, node number 3, we wrote zeta is equal to 1. Okay. Now next, come to second back face. Now back face, if you consider, again which consists of 4 nodes. Okay. In the back face, it is behind the origin. Origin is exactly at the center. Okay. Which is this back face is behind the origin. Then it is opposite to the direction of zeta. Then zeta is equal to minus 1. The back face natural coordinate value is zeta is equal to minus 1. Hence the nodes of this face, node number 5, zeta is equal to minus 1. Node number 8, zeta is minus 1. Node number 4, zeta is minus 1. And node number 1, we wrote zeta is minus 1. Okay. Now next, these two faces we have considered in zeta direction. Now let us consider in neta direction. In neta direction, these faces will come in neta direction. Okay. Now this face is to the right of the origin. Hence in the direction of neta, for this face neta is equal to plus 1 for this face. Hence the nodes 7, 8, 3 and 4, we should write neta is equal to 1 like this. Neta is equal to 1. Neta is equal to 1. That is second term. Neta is equal to 1. Next, in this face is to the left of the origin, which is opposite to the direction of neta. This face, the natural coordinate value is neta is equal to -1. Hence, for all the nodes of this phase, that is node number 6, neta we wrote -1, node number 5, neta is -1, node number 2, neta as -1, and node number 1, neta as -1 we wrote. Okay, now next come to considering phi direction. Now considering phi direction, we have again top face and the bottom face. Okay, now top face, it is above the origin. Okay, hence here for top face phi is equal to +1. Then the top face consisting of node number 5, 6 and 7 and 8. 5, 6, 7 and 8. Here 5, 6, 7 and 8. Phi is equal to 1, you write. Phi is equal to 1, phi is equal to 1, phi is equal to 1. Next, the bottom face. Now the bottom face, if you consider, which is below the origin in phi direction, opposite to the phi direction, then for bottom face phi is equal to -1. You write the nodes for node number 1, phi is equal to -1. And for node number 2, phi is equal to -1. For node number 3, phi is equal to -1. For node number 4, phi is equal to -1. Like this, as you write the natural coordinate values of the all these 6 faces, we will come to know the natural coordinate values of all the 8 nodes. Like this, you just write the natural coordinate values of these nodes 1, 2, 3, 4, 5, 6, 7, 8 in this fashion: zeta, neta and phi. Zeta is this direction, neta is this direction, and phi is this direction. Okay, now we will determine the shape functions n1, n2, n3, n4, n5, n6, n7 and n8 by using the general expression. Now the general expression for determining the shape functions n1 to n8 for hexahedral element is given by this one. Okay, using the Lagrange method of shape function, all the shape functions n1, n2, n3, n4, n5, n6, n7, n8, the Lagrange formula for Lagrange shape function for n1 to n8 can be written as in a general form, that is given by ni is equal to 1 plus zeta 1 by 8, that is ni is equal to 1 divided by 8 into bracket 1 plus zeta I into 1 plus neta I into 1 plus phi into phi I. Okay, this is what the general form of shape function for determining the shape functions n1 to n8. This ni is equal to this general form. From this expression we can find n1, n2, n3, n4, n5, n6, n7, n8. Okay, to find where I is equal to here, where I is equal to 1, 2, 3, 4, 5, 6, 7, 8. Okay, if you are determining the shape function n1, then put I is equal to 1 here, then it will become n1. Then you find right here I is equal to 1 here, then 1 plus zeta 1 into bracket 1 plus neta 1 into bracket 1 plus phi 1. You just write zeta 1, neta 1, phi 1, that is the coordinate values of the node 1. You substitute here from the figure. Okay, after that you will get n1. Likewise, similarly, you find n2 by substituting the coordinate values of the node 2. You find n3 by substituting the coordinate values of the node 3. You find n4 by substituting the coordinate values of the node 4 into this general form. Up to n8 you adopt the same procedure. Similarly, you find all the shape functions n1, n2, n3, n4, n5, n6, n7 and n8. Here you can observe this one. This is the general form of expression to find the shape functions. Now at node 1, we know that the coordinate values which is been now just discussed in the previous page, you just go through that, my dear students, and those natural coordinate values from that particular figure, you just write down the node 1 natural coordinate value. Zeta is -1, neta is -1, phi is equal to -1. Okay, then I is equal to 1. If you put n1, we will get by substituting the values of natural coordinate values of node 1. If we substitute zeta 1, neta 1 and phi 1 -1, then we will get 1 by 8 into bracket 1 minus zeta 1 minus neta into 1 minus phi. This is what the shape function n1. Now shape function n2 can be obtained by substituting the coordinate values of node 2 into this general form of expression for ni. Then we will get n2 is equal to 1 by 8 into 1 plus zeta into 1 minus neta into 1 minus phi. Next, the shape function n3 can be found out by substituting the coordinate values of the node 3 into this general form of expression. Okay, where here zeta I is neta I and phi I will become zeta 3, neta 3, phi 3. You just substitute these natural coordinate values here. We will get n3 as 1 by 8 into 1 plus zeta into 1 plus neta into 1 minus phi. Likewise, similarly, to find shape function n4, substitute the coordinate values of node 4 into this expression. To find shape function n5, substitute the coordinate values of node 5 into this general form of expression. Okay, to find shape function n6, substitute the coordinate values of node 6 into this expression. To find shape function n7, substitute the values of coordinate values of zeta, neta, phi of node 7 into this expression. And to find the shape function n8, substitute the coordinate values of node number 8 into this expression. We will get the shape functions n1 to n8. This is how we can derive the shape functions for hexahedral element 8 shape functions we can derive by using the general form of Lagrange shape function. Okay, I hope you have understood, my dear students. It is very simple. Okay, now this is very simple. If you use Lagrange method of a shape function formula individually, if you find n1, n2, it will be time consuming. Still we will check it out whether this general form of expression, just we will verify. Randomly we will select one of the shape function and we will verify whether it is correct or not. Okay, now n7 I will find, let us say n7. To find a shape function n7 by using Lagrange method of shape function. Now n7 in zeta direction, there is one node, that is 8, node number 8. Then if you write the formula zeta minus zeta 8 divided by zeta 7 minus zeta 8. Okay, now for zeta 7 value is 1. Okay, zeta 7 is 1 and zeta 8 is minus 1 is there, that is minus 1. Zeta 8 is minus 1. Okay, zeta 8 is minus 1. Then we will get zeta minus of minus 1, we will get zeta plus 1 divided by, okay, what is this, 1 minus of minus 1, we will get 2. Okay, 2 will get zeta plus 1 divided by 2 we got. First ratio we got zeta plus 1 divided by 2 for n7. n7 is equal to, multiplied by, in neta direction, this is the neta direction. In neta direction there is node number 6. Node number 6. Okay, now from this we can write the using Lagrange method of shape function neta minus neta 6 divided by neta 7 minus neta 6. Okay, now what is neta 6 here? Neta 6 is minus 1, we know it is minus 1. Okay, and what is neta 7? Neta 6 is minus 1. Neta 7 is plus 1. Okay, now if we substitute neta minus of minus 1 will become neta plus 1. I will write here neta plus 1. Okay, and here 1 minus of minus 1, it will be 2. 1 plus 1, 2. Okay, we got 2 ratios. And one more, next, into again in phi direction. In phi direction is this one. For node number 7 in phi direction there is one more node, that is node number 3. Then it is phi minus phi 3. Phi minus phi 3 divided by phi 7 minus phi 3. Okay, what is phi 3 value? That is minus 1. Phi 7 value, it is plus 1. Okay, phi 3 is minus 1. We will get phi minus of minus 1, phi plus 1 divided by, and phi 7 value is 1. Phi 3 value is minus 1. Okay, then we will get 1 minus of minus 1 will be 2. Okay, we got zeta plus 1, neta plus 1 and 5 plus 1 in the numerator. Denominator 2, 2, 2 is there. It is multiplication. Then we will get, if you multiply 2 2s are 4, 4 2s are 8, the denominator will get 8, and numerator 1 plus zeta into 1 plus neta into 1 plus 5. Okay, it will be somehow little bit time consuming because you need to write all these ratios and substitute the values, and you will get the shape function. Just randomly we have selected n7. If you compare n7, we got 1 by 8 into bracket 1 plus zeta into 1 plus neta into 1 plus 5. Okay, now we will compare. You can observe here. Now n7 we have calculated. N7 we got 1 by 8 here, 1 plus zeta into 1 plus neta into 1 plus 5. The same expression we got by using that formula. Okay, that's why instead of writing those equations directly, you can write the general form of expression for Lagrange shape function. This one, just you substitute the coordinate values directly into this equation, we will get respective shape function. Okay, one more method also we will discuss now, so that we will verify. That is one of the method for 9 node quadrilateral element. We have derived the shape functions for 9 node quadrilateral element using the conditions. That is n1 is that is shape function is 0 on other sides, and it is equal to 1 on the sides through which the that node is passing, like that. Okay, now from by using that, okay, let us say I will consider okay, let us node number 1. If you consider node number 1, okay, for this n1 is equal to, I will write n1 is equal to, I will write the equation, that is by considering the constant c1. Okay, now the n1 is 0 on the faces. On which face? See here, n1 is 0 on this right side face, because this face will not pass through the node number 1. Okay, now next come to this top face. This face will not pass through node number 1. Okay, and next this face and this face, and one more is front face. Okay, because node number 1 is on the back face. Okay, now n1, node number 1, shape function n1 is 0 on the front face, right side face, and on the top face, because it will not pass through, these faces will not pass through node number 1. Now we will write the equations for this face. We know the top face, the equation for this face is natural coordinate value is phi is equal to plus 1, and for this face the neta is equal to plus 1, and for the front face, which is in zeta direction, here zeta is equal to plus 1. These three expressions we got. These three expressions can be written as 1 minus zeta is equal to 0, 1 minus neta is equal to 0, and 1 minus phi is equal to 0. And since n1 is equal to 0 on these faces, where these faces will not pass through node number 1, then we should write the expression. These terms have to be included in this expression. What is that? C1 into 1 minus zeta, okay, into 1 minus neta into 1 minus phi. Like this we will write n1 equals to c1 into 1 minus zeta into 1 minus neta into 1 minus phi, because where zeta is equal to 1, neta is equal to 1, and phi is equal to 1, we got from those expressions we will get 1 minus zeta is equal to 0, 1 minus neta is equal to 0, and 1 minus phi is equal to 0. Okay, now we know that now we will find the constant c1 by substituting the values of the coordinate values of node 1 here, and n1 is equal to, we know n1 is equal to 1 at node 1. At node 1 n1 is equal to 1. If we substitute n1 is equal to 1, c1 into bracket 1 minus of, okay, here zeta, neta, and phi values are minus 1, minus 1, minus 1. Then we will get 1 minus of minus 1, 1 plus 1, 2. And again neta is minus 1 here at node 1, minus 1 minus of minus 1, that is plus 2. Again neta phi is minus 1 here, 1 minus of minus 1, that is plus 2. Okay, we will get 2 2s are 4, 4 2s are 8. We will get, okay, sorry, okay, okay, now here we will get Okay, here we will get C1 is equal to 1 divided by 8 we got. If we substitute C1 is equal to 1 by 8 here, we will get N1 is equal to, therefore N1 is equal to 1 by 8 into bracket 1 minus zeta into 1 minus neta into 1 minus phi. This you can verify. N1 we have calculated just now. See, N1 we got 1 by 8 into bracket 1 minus zeta into 1 minus neta into 1 minus phi. The same expression we got. Okay. This is little bit lengthier. You use, my dear students, you use this general form of expression to determine the shape function and substitute all those coordinate values to get n1 to n8 shape function for hexahedral element. This is how we can derive the shape functions for 8 node hexahedral element n1 to n8. Okay, thank you my dear students. Thank you. Take care, stay safe, stay healthy.